Yesterday we were talking about properties of parallel lines, and so today we're going to look at proving that lines are parallel to one another. So there's going to be some techniques that we'll pick up today to be able to prove whether or not two lines are in fact parallel, or multiple lines for that matter. And we're going to start off again, as usual, with the vocabulary. Now, this vocabulary is something that we have actually not covered because we did not do the proofs and reasoning section of this textbook and of this curriculum that was set forth by the state. They eliminated the proofs and reasoning section, so we're going to kind of pick this up as we go along. And what we're given here are two statements in questions 1 and 2. And for both of these, it asks us to write the converse of the statement. So in each one of them, you see a phrase that is in red and then a phrase that is in blue. The phrase in red is your hypothesis, and then the phrase in blue is your conclusion. So to create a converse, you just simply flip the hypothesis and the conclusion. So for number 1, instead of saying if you are cold, then you wear a sweater, what you would say on this one is if you wear a sweater, then you are cold. So number 2, it says if an angle is a right angle, then it measures 90 degrees. Well, the converse of that would be if an angle measures 90 degrees, then it's a right angle. And I'm going to use some shorthand to save time. And for number 3, it's asking us to determine whether or not the converse of a statement is always, sometimes, or never true. Well, if we look at statement number 2, if an angle is a right angle, then it measures 90 degrees. Its converse is absolutely true. If an angle measures 90 degrees, then it's a right angle. However, if you look at number 1, it says if you are cold, then you wear a sweater. The converse, if you wear a sweater, then you are cold, is not necessarily true. Some people just like to wear sweaters. So the converse statements are going to be sometimes true. Okay? So converse, you just simply take the hypothesis and conclusion, flip their places in the statement, and you've created the converse, and the converse statement is sometimes true. The vocabulary builder for today, yesterday we looked at interior, today we're looking at exterior. So exterior is going to be, in this case, anything that is outside of these two lines. Using the vocabulary, again, sometimes, like I said, these get a little goofy. To paint the outside of your house, you buy interior or exterior paint. The protective cover prevents the interior or exterior of the book from being damaged. That prevents the exterior of the book from being damaged. Now we're going to get into some geometry. In the diagram at the right, angles 1 and angle 7 are alternate interior or exterior angles. Well, we can see that both of those angles are on the outside of the parallel lines, so they are exterior angles. In the diagram, angles 4 and 5 are same side interior or exterior angles. Well, because both angles lie inside the parallel lines, they are interior angles. For 8 and 9, we just want to underline the hypothesis and circle the conclusion in the following statements. So this refers back to what we did at the very beginning when we were writing the converse. We're going to identify the hypothesis and then circle the conclusion. The hypothesis is typically indicated by the word if, and then the conclusion is typically preceded by the word then. So in this case, lines do not intersect, they are parallel. That is our hypothesis and our conclusion. If the angle measures 180 degrees, then it is a straight angle, and that is your conclusion. We're going to introduce a couple more postulates today. The corresponding angles postulate and the converse of the corresponding angles postulate. The corresponding angles postulate: if a transversal intersects two parallel lines, then corresponding angles are congruent. Number 10 says to complete the statement of theorem 3.2 or 3.2, or postulate 3.2 rather. If two lines on a transversal form corresponding angles that are congruent, then the lines are, and that's going to complete this positive for us. If the two lines on a transversal form corresponding angles that are congruent, then these lines are parallel. And what that's simply saying, if I just arbitrarily draw two lines, we're not going to assume yet that they are parallel, and then I draw this transversal through those lines. If this angle and this angle, because they are corresponding angles, if they are congruent, then we've been able to prove that, I'm going to label this A and B, that lines A and line B are parallel to one another. So using the diagram below, place the appropriate markings to show that angle 1 and angle 2 are congruent, and that's just very simply putting in those congruency symbols that we've seen many times before. And then finally, number 12, circle the diagram that models theorem 3.2 or postulate 3.2. Postulate 3.2 just says if two lines on a transversal form corresponding angles that are congruent, then the lines are parallel. In this first diagram, we have alternate exterior angles, so those are not corresponding. But in the second diagram, we do have two corresponding angles that are congruent, so that means that lines L and M have to be parallel. Now we're going to jump down to a couple of theorems, and we have the theorem 3.4 is the converse of the alternate interior angle theorem. It says that if two lines in a transversal form alternate interior angles that are congruent, then the two lines are parallel. So that's just taking the alternate interior angle theorem and flipping it around. We've taken the hypothesis and conclusion, and we reversed their locations. Same thing with theorem 3.5. It's the converse of the same side interior angles theorem. If two lines in a transversal form same side interior angles that are supplementary, then the angles are parallel, or the two lines are parallel. And then theorem 3.6, the converse of the alternate exterior angles theorem. If two lines in a transversal form alternate exterior angles that are congruent, then the two lines are parallel. Using the diagram at the right, we're going to complete each example. For theorem 3.4, which is the converse of the alternate interior angle theorem, if angle 4 is congruent to, so here's angle 4, and we're talking about alternate interior angles, so the alternate interior angle to number 4, or angle 4, is angle 8. If those two angles are congruent, then lines B and C have to be parallel. Theorem 3.6 or 3.5 is if angle 3 and some other angle are supplementary. So we're looking at angle 3, and the converse, this theorem that we're using is if two lines form same side interior angles that are supplementary. So then that means it would have to be angle 8. If angle 3 and angle 8 are supplementary, meaning they add up to 180 degrees, then lines B and C have to be parallel. Theorem 3.6, if angle 1 is congruent to some other angle, then B has to be parallel to C. And that theorem says if two lines in a transversal form alternate exterior angles, so we're looking at angle 1, and the alternate exterior angle to that is angle 7. So if angle 1 and angle 7 are congruent, then lines B and C have to be parallel. All right, so now we get into our first problem. We're identifying parallel lines. We're going to underline the correct word to prove each sentence. We want to justify or find which lines are parallel if angle 6, so we're talking about angle 6 is congruent to angle 7. So angle 6 congruent to angle 7, is that given, or do we need to prove that? Well, that is a given statement. Angle 6 and angle 7 are alternate or same side angles. They are same side angles. They're on the same side of this transversal B. Angle 6 and angle 7 are corresponding exterior or interior angles. Well, they're both, they can't both be exterior and they can't both be interior, because angle 6 is interior and angle 7 is exterior. So these are corresponding angles. And then we can use postulate 3.1 or 3.2 to prove that the lines are parallel. So if we go back up to those postulates, 3.1 says that the corresponding angles are congruent. 3-2 says that if they form corresponding angles that are congruent, then the lines are parallel. So we don't know. We can't use 3-1 because it is based off of lines already being known to be parallel. So we have to use postulate 3-2 because we know something about the angles, and then that will allow us to prove something about the lines. So using that angle 6 and angle 7 are congruent lines A and B or L and M. So we know that it's going to be lines L and M because B is our transversal, our parallel, and the transversal, as I just said, is line B. All right, writing a flow proof of theorem 3-6. So given that angle 1 is congruent to angle 7, prove that angle 3 is congruent to angle 5 using a flow proof. Use a diagram at the right to complete the flow proof. Wow, can't speak this morning. So we're given angle 1 is congruent to angle 7. That's already given to us. And we also have that angle 1 is congruent to angle 3. So if we look at angle 1 and angle 3 right here, we know that those are vertical angles. And we know that vertical angles are congruent. So then we have angle 3 is congruent to angle 7. Well, because of our first two statements, angle 1 is congruent to angle 7 and angle 1 is congruent to angle 3, then we can make the statement that angle 3 has to also be congruent to angle 7 by the transitive property. Transitive property of equality. And then we have angle 7 is congruent to some angle because, and the statement or the reason is given right here, vertical angles are congruent. So the angle that is vertical to angle 7 is angle 5. And then we have angle 3 is congruent to angle 5, and again, that because of these two statements, it's the transitive property of equality. All right, and problem number 3, determining whether lines are parallel. Given that angle 1 is congruent to angle 2, we can use the converse of the alternate exterior angles theorem to prove that lines R and S are parallel. What's another way to explain why R is parallel to S? So we're going to justify each of the steps that we're already given. We're looking at justifying that angle 1 is congruent to angle 2. And any good proof should always start out with what is given. Then we have angle 2 is congruent to angle 3. If you look at the diagram, you can see that those are vertical angles. And then we have angle 1 is congruent to angle 3, and we've simply just gone from this step to this step to this step by using the transitive property of congruence. Angles 1 and 3, angles 1 and angle 3, are they alternate or corresponding? Well, they're on the same side of the transversal, so they have to, in this case, they have to be corresponding. And what postulate or theorem can you now use to explain why R is parallel to S? And that is the converse of the corresponding angles theorem. All right. Oh, crud. There we go. All right. And our last problem before we do the lesson check. We want to find the value for W that would justify, or that would actually make line C parallel to line D. So we want to underline the correct word to complete each sentence. The marked angles are on, in this case, here's 55. Here's the other angle with the algebraic expression. They are on the same side of the transversal. By the corresponding angles postulate, if line C is parallel to line D, then the corresponding angles are congruent. And then so to simply solve this, we would just set both angles equal to one another. If they're congruent, they have the same angle measure. So we have 3W minus 2 is equal to 55. We'll add 2 to both sides. Divide by 3. and we get 19. All right, so W has to be 19. And then finally on the lesson check, it says a classmate says that line AB is parallel to line DC based on the diagram at the right. Explain your classmate's error. Circle the segments that are sides of angle D and C. Underline the transversal. So we have BC is a side that is, it contains angle C. DC contains angle C. And DA contains angle D. DC is our transversal. It said to underline that. So explain what your classmate's error is. The classmate simply identified the wrong pair of parallel sides. Angle ADC, so angle ADC, and angle BCD. Let me do that one in blue. So this angle and this angle are same side interior angles. And the transversal, in this case, we would consider to be DC. So AD is parallel to BC by the converse of the same side interior angles theorem. I'm not going to write all that out. If you need to replay that to hear it again, I'll say it one more time. We had angle ADC, that's what I've drawn there in red, and angle BCD, which I've drawn in blue, are supplementary. They add up to 180 degrees, and they are same side interior angles. So AD and BC are parallel to each other by the converse of the same side interior angles theorem. That's the end of this set of notes. I hope you guys are having a great day, and I'll be actually talking to you all shortly.